I'm not going to introduce our first speaker. I'm going to keep our introductions relatively brief so we can spend most of the time on the talks. I might also mention at the end of the day, we will have a panel discussion that for a short period of time will take questions from within the audience and also online. There are quite a number of people who have registered online, and I hope more will join. So our first speaker is Professor Erling Norrby, who is has been very closely associated with the Nobel Prize. He began at the Karolinska Institute as a professor of virology, rapidly became dean, and was associated with the Nobel Prize for Physiology or Medicine for 20 years, and at one time chaired it. He's also then went on to the other domains of science, becoming the permanent secretary of the Royal Swedish Academy of Science for a long time, and therefore was closely associated with the awards in chemistry and physics. And he also has taken on him the only major task of writing what were the results of the Nobel Prize winners, who they were, in 5 books that he's written that describe not only what happened and what the Nobel Prize meant, what the discovery meant, but also what happened to it later in terms of its development. So it's my great pleasure to welcome Dr. Erling Norrby, a close friend and great scholar.
It's a great pleasure and an honor, of course, to be the first speaker on this very exciting afternoon that we're going to have together in discussing and recognizing the 100 years anniversary of the Nobel Prize, Physiology and Medicine to Banting and MacLeod. And I've taken the liberty, actually, of calling it the optimal Nobel Prize in Physiology and Medicine. And you can debate that back and forth, and we will do that as we go along. But really, what was Alfred Nobel's ambition in formulating Nobel Prizes? What you see here is just a small part of his will, and it's handwritten. He has created it all by himself, no legal advice. And he said that he wanted to create the 5 different prizes. And this would be prizes in physics, prizes in chemistry, and a very important point, in physiology or medicine. He realized that modern medicine, or the way medicine was developing, was depending on the fundamental research that allowed us to understand the disease processes and so forth. And then there was a prize in literature, and that should be literature written in with an idealistic orientation, which is a bit of a difficult formulation. So it meant for the first 10 years, one missed out Tolstoy, Ibsen, Strindberg, or what have you. But this is not what I want to talk about today, but about the prize in physiology and medicine. And then, of course, there's a Peace Prize. And it was defined in this very incomplete will, one should say, the responsible organizations. So it was the Royal Swedish Academy of Science that was responsible for the prize in physics and in chemistry. And it was the Karolinska Institute that was responsible for the prize in physiology and medicine, the Swedish Academy of Letters for literature, and a committee in Norway under the parliament there that was going to be responsible for the prize in peace. And it should be reminded this time, when the will was written and when the first Nobel Prize were developed, Sweden and Norway were in a union, and that was dissolved in 1905. The real problem with this will is that it's not specified who is going to get the money. And therefore, once this will one knew the intentions of the donor here, there were lots of discussions. So first of all, not all those that were pointed out to be the ones responsible for the prizes were enthusiastic about it. The Karolinska Institute was a little hesitant, and there were other problems along the road. But what to do about the absence of someone who could take care of the money? So therefore, one created something that is called the Nobel Foundation, and that is not specified in the will. And that Nobel Foundation is responsible for managing the money, for controlling the legal aspects of the prize, and to arrange the feast, which is, as you could probably know, many of you, extraordinary feast that always happens on December 10th, which is Alfred Nobel's death day. So finally, one had this in place, and finally one had an agreement between those who were selected to provide the prizes. And 1901 is the first year that the prizes could be awarded. There's a good reason for the delay here. Now, perhaps a few words also then about, and I'll focus mostly on that, on the Karolinska Institute and the prize in physiology or medicine. At this time, the Karolinska Institute was not a fully matured university. It has been a fight since 1810 between the Uppsala University and the Karolinska Institute, and very reluctant had the Uppsala University allowed that transfer of responsibility was given to Karolinska Institute. But still in 1901, Karolinska Institute could not graduate its own doctorate students. That came in 1908. So just to give you a perspective on where we are. In order to emphasize the Karolinska Institute, I wanted to bring forward this particular person, Jens Jakob Berzelius. And he was perhaps best known because he was the permanent secretary of the Royal Swedish Academy of Sciences. And he carried this responsibility for 30 years. So he truly was a permanent secretary. So I am a former permanent secretary, and we're a number of former permanent secretaries that are now out there and enjoying the responsibility of knowing about the Nobel Prizes. This is, this slide highlights some critical things. So it was a college of teachers that was responsible to take the decision on this. And then gradually one created a Nobel committee that was supposed to do the work. And the members of this committee were appointed for 3 years with a possible prolongation for 3 years. And the number of people in this committee increased progressively from 3 and later up to what in the 1960s was there were 5 members of the committee and 10 adjunct members. And of course, the field of medical science is very large, so you need to have representation for both the basic sciences and for the clinical sciences. And the appointment on the committee is for 3 + 3 years. And originally, the final decision was taken by the College of Teachers. And this College of Teachers continuously grew, of course. And in the 1970s, we were some 64 members on the College of Teachers. Then there was a change in the rules of secrecy laws for the Karolinska Institute. So one did something that I think might have been legally not incorrect. One created something called the Nobel Assembly. And the Nobel Assembly, which was created in 1977, has 50 members. So since at that time we were 64 members in the College of Teachers or in the faculty, so as it was later called, it was progressively reduced. So the way the system works today is that you have a committee of 5 people, 10 adjunct people, and that interact with the 50 members in the Nobel Assembly, which actually is a pretty good composition. So this is a little about the background to this. What about the Nobel year? When does the Nobel year start? Nobel year is longer than 1 year. If you start in the internal part of the yellow part here, you can see that we control the process completely so that only people invited by us have the right to nominate. So therefore, it all starts by sending out invitations to nominate. And there are certain rules for that. And in the beginning, of course, you probably was working with some 30, 40 nominations. Today, we're working on the order of 500, or at the Karolinska Institute, even 700 nominations. So it's quite a task to sieve out and identify the most appropriate recipient of the prize. I never use the word that you're a winner of the Nobel Prize. I want to emphasize this is not a lottery. It's something different. You are selected by a committee that makes very careful work on this and that. So nominations should be submitted before the end of January 31st. There is an opportunity for members of the committee or involved in the prize work to look at the nominations on the last day and say, oh, I would like to supplement this with another nomination. And that's actually been used, that I'll show in one of the slides. And from there on, the work runs on, and then you have various reviews or various in-depth reviews. Many of the professors at the Karolinska Institute spend a good part of the month of August writing reviews for the Nobel Committee. That's a part of their summer vacation. And it's a learning experience. And then this is picked up by the committee, and the committee towards the end of September comes out with a proposal to the Nobel Assembly when we talk about the Karolinska Institute, and then the final decision is taken in with the rule we now have, always the first full week in October, with physiology and medicine on Monday, physics on Tuesday, chemistry on Wednesday, and literature on Thursday, and peace on Friday. So that's the way it works. And the important point here is that we control the whole process of this. And it's just to illustrate this. I just took out for the 1 year, 1969, the documentation for prizes in chemistry and physics. These are thousands of pages. And this is serious work. Now, this material has a secrecy period of 50 years, which is very long. And of course, there's a purpose of that. And but after 50 years, you can ask for permission to look at the archives. And that's what I've been doing for the last 15 years. And that has resulted in 5 books. Here are 4 of them. And the first book being more of a general review, providing a background to the whole thing. And from there on, it runs with the up to the top right, between prizes, mostly in physiology and medicine, 60 to 62, and then 63 to 65, and 66 to 68. And you can see in the titles here, and putting on the last book, what the dynamics are. The Nobel Prize in 66 to 69, it's a cancer prize. It's a prize for the seeing physiology, and this is a genetic code. These are really fundamentals in biomedicine. And the prize in cancer, actually, one of the co-recipients was Huggins. Huggins was born in Canada, but the work was done in the United States, in Chicago. And so this is a particular challenge that we may come back to. So use these archives, which are world unique historical archives, because they express the state of knowledge at that particular time. It helps to be a Swede because they all written in Swedish. But today, of course, where you have immediate language translation, and that can be resolved. And with time, when we're coming into the 70s and 80s, we started to use international reviewers. But most of it has been done in-house, and it is an in-house responsibility now. So in the first book, I won't elaborate on this, but just to emphasize, these are Nobel Prizes in physiology and medicine that I found have been awarded the fourth year nomination. And they, by definition, you find Banting and MacLeod here because the nomination was for 23 and they received the prize in 23. And there are some other examples all the way into 58, in fact, where you have this situation. And the other thing is a situation where there's no nomination from without, and you still get the prize. How can that happen? Well, someone in the committee that's involved in this. And here we can look at the first one, 1920, August Krug. He was reviewed in 1919, and actually members of the committee went to his laboratory in Copenhagen to check on the plate, what's going on. And that was the old way of controlling this. And then, but then there was no nomination in 20. So a member from the committee nominated him, and he got the prize that year. And he, as you know already, is a central figure in our story. And he's quite a giant in physiology, and his wife was also a very, very qualified scientist, Marie. And he made several contributions. But apparently he was also a smart businessman. I won't elaborate that, but the deal he made with MacLeod that allowed for the development of what today is called Novo Nordisk is a great success story of how you can implement knowledge into an effective production of drugs in a pharmaceutical company. Now, so let's come to the events in 1923. So August Krug was the one nominating Banting and MacLeod. You see, he's the only one who did that. It should be reminded here that this is now in early 23, but there had been a lot of discussions already in Edinburgh in the middle of the summer, the year before in 22. So there was the chairman and the secretary of the Nobel Committee and the two reviewers, and they could listen to Banting. They could listen to MacLeod. And I think this is important. That it was not something that evolved during the autumn, but it was there as a relevant discussion. And then you see there was one nomination from MacLeod, two for Banting, and then there were those that were nominated later, and they were all for Banting. Now, two very important figures in this work, Jöns Johansson, he was the chair of the Nobel Committee in 1980 to 1926. Jöns Johansson had worked with Alfred Nobel in Paris, and he was probably the one who built up a unique trust between Nobel and the Karolinska Institute. Nobel could have chosen the Uppsala University or something like that, but he had this contact with the Karolinska Institute, and he, in fact, had donated money to the Karolinska Institute before the will. And Göran Liljestrand, as a professor of pharmacology, he was a secretary of the Nobel Committee between 1980 to 1960. You can imagine that he carried along quite a perspective, and it is said that he could write the protocols before meetings later on in the work, but that's of course just a little way of playing the whole thing. The critical reviewers, there were the professor of chemistry and pharmacy called Sjöqvist, and he had been at the Edinburgh conference, and he and all this is originally in Swedish, but then it's I have translated it to English. So his perspective is, it's my personal opinion that the discovery of insulin in the pancreas, studies of its physiological effects, and its introduction into therapy is of a scope that can be rewarded with Nobel Prize Physiology Medicine. It's not overwhelming, but it's clearly another, that's a solid mandate. When it comes to possible awarding the prize and it's distributed, I sided with the nominator Krug, and he probably was influenced by that. He had been involved in Krug's prize before, which opinion should be given jointly to Banting and MacLeod. The honor of the idea and initiative go to Banting, but as can be judged from publication available and assertions from associated person, this is the way I have to build up the impression, MacLeod at whose department the investigation had been conducted, has been the leader of the scientific investigations. And man emphasized also his involvement in carbohydrate metabolism. The second reviewer was a professor of medicine called Christian Jacobeus, and he is a little more vague in his formulation, but still his conclusion is the same. On the other hand, it's more difficult to decide on MacLeod's contribution since it's not apparent from the literature. Well, that can be debated, no matter what we know today. And there are also citations that were criticized. I have been told that it's very likely that the discovery would not have been made if MacLeod had not supervised him. We don't know who told him that, but there could have been something at the Edinburgh conference. And anyhow, his conclusion is that should be given to both Banting and MacLeod. But there was a certain unrest in the group, and here's a critical professor of general healthcare. During the time I've participated in awarding the Nobel Prize, the justification for an award has never been based on hearsay evidence from unknown persons or statement like it is beyond and so forth. However, this gentleman had his own fishes to fry because he had another candidate. And that's the way the chamber play plays out. So he wanted to give, there's a strain of bacteria called Haemophilus influenza. And it was thought at this time that was a cause of influenza, which is wrong. So it's fortunate that one didn't give a Nobel Prize to Pfeiffer, who was the father of the Haemophilus influenza concept. And it wasn't until 1933 when one for the first time could isolate the virus that causes influenza. It's that late. A lot of people think that we diagnosed the 1918 terrible pandemic that hit the young people, but there was no diagnosis at that time for influenza. Now, so here, then decision is taken on October 18th, and because of that it took some time apparently, and those were the days when traveling took time. Neither, as you all know, Banting and MacLeod could join for Nobel festivities. The diplomas were, of course, printed the way they usually are, and it's quite elaborate, and it's changed somewhat with time. But this is the outside of Banting's diploma, and it's signed by all the members of in this case, 19 members of the Nobel or the College of Teachers. So everyone was involved in this, and this is the document that we were looking at this morning. In fact, in a fantastic collection. One also get not only diploma but a golden medal, which actually is a heavy golden medal of solid gold, and it shows the richness of the Queen of Hygiene, showing that she's providing water to the sick lady on the right, and at the same time reading a book, which kind of split activities. But it's a beautiful medal, and that it can become very expensive. In particular, it has belonged to one of the spectacular Nobel laureates. So I would mention that it's given on December 3rd, Nobel's death day, and the Swedish royalties have always been present in one form or the other, mostly in form of the king. The present king, if he hangs in there, and the next year he has awarded Nobel Prizes 50 times, 50 years. So the British Minister of the Commonwealth was the one who transported himself to Stockholm and received the prize. But I haven't, and apparently no one else has found a picture of that when the diploma is handed over to the minister and so forth. So the Nobel lectures, they came much later, and you read those, they're rather uneventful. I think they are kind of describing the two perspectives that is provided. But one was, MacLeod was given in May 1925, which is 2 years later, and in September 1925 from Banting. Of course, they couldn't travel together and give lectures. So what about the collaborators? And a lot of you here who know much more about this particular situation. What I've learned is simply by reading about the fantastic books that there are about the whole story. So it was Charles Best that was a very close and very young collaborator. I think he was only 22 or 23 at that time. And he was, and as you also know, he was was awarded half of Banting's prize, actually. So the prize was split into quarters, as you all know. But he then later on was trained by Henry Dale, and I made a feast with him. And Henry Dale is a Nobel laureate from the 1930s, and he was nominated later on and evaluated by von Euler, who is a Swedish Nobel laureate from 1971. And there was a lot of enthusiastic rewards. So he was nominated 14 times between 50 and 54. The main nominator was Henry Dale, which was a heavyweight nominated because they supervised Best's PhD work. And the discovery prize to be awarded was best work on the lipotropic effect of choline. Now, I don't know much about that or what value it has, but he was declared worthy of a prize. So we have not a very nuanced formula. We can declare people worthy of a prize. We can say that not as yet worthy of the prize or not worthy of the prize. These are the three alternatives. It doesn't help us more because if you look at the protocol or the conclusion protocol, you end up with 50 candidates or plus minus a number that are worthy of a prize, but there's no grading. So that I won't elaborate that, but the work we do in physics and chemistry is better in the sense that they take out the 5-6 strongest prize contestants and have a separate discussion on why in a particular year one selects one of them. At the Karolinska Institute, you have to have this list, the protocol of some 50 plus, if we're now into 1960s, prize-worthy candidates, and this year we propose the one candidate. So Best had a little of what we call, or what I have been referred to as Nobeliasis. He would have loved to get that Nobel Prize, but that's not. And you will be surprised how many people that are waiting at the telephone the day when we announce the prize, and all the disappointments that there are. And so clearly, the prestige. This is the most exceptional prize in the world, and a lot of people wanted to share it. And a lot of people want to be nominated. And if you don't carry that further, I can tell you a story about a good friend of mine who was really hunted by a colleague who wanted to be nominated. So eventually, my colleague said, "Okay, I'm going to send a letter to Stockholm." Yeah, so. And he did, and he sent it to me, and I could put it in the wastebasket. But don't carry that story further. And James Collip, when I read on this and in the books, I think it's very, very essential what he did. The chemical purification of insulin that allowed it to be used in humans. Isn't that the key final thing? And he, as you also know, he received half of McLeod's prize money. He was also nominated for Nobel Prize 11 times between 28 and 56, and carefully evaluated as a bona fide candidate is, and but it was not considered worthy of the Nobel Prize, so he was never really tested. And then now, just a few words on what happened after the identification of the very central physiological role of insulin and the capacity to purify it, and came to be a lead compound in many different further developments in the advance of science. And we can just start with, because it was the first biologically active protein that was really could be purified in large quantities. And therefore, when Frederick Sanger in the end 40s and beginning 50s made a fantastic work, I mean, he is such a brilliant scientist that eventually could describe insulin as having two chains, having the three disulfide bonds, and this opens more than a new world than what you think, because at this time, and I have reviews by Hugo Tyrell, the Swedish Nobel laureate of 55, in from 53, when he wonders about how on earth can nature produce a protein, and are all proteins the same, or is there a preference for amino acids to interact and so forth? The concept of a code did not exist in 1953 in protein chemistry. It came later in 1954. Once you had DNA, then all by suddenly one understood nature hasn't made things more complex than what it need to be. There are 4 letters. They're going to define the position of 20 amino acids. What do you need? A triplet code. Okay, but that's 60 combination. That means that it's a code of redundancy, but you need some start and stop code and so on. But that came as a consequence of the discovery of the structure of DNA, but it was then could be applied to the analysis of insulin by Sanger. And Dorothy Hodgkin, and a fantastic woman, the third woman to get the Nobel Prize in chemistry. Who was the first? Madame Curie, of course, 1911. Second, her daughter, Joliot Curie, in the 37, I think. And then she's the third one. And it's all a little puzzling because I gave a Nobel Prize in chemistry in 1960 to the two male crystallographers, but Dorothy Hodgkin had to wait these 2 extra years. But that gave her a privilege, actually. Normally, the king has on his side the wife of the prize in physics, unless it happened to be a female prize recipient, which is sadly a bit rare. But then this year he took Dorothy Hodgkin, and she was the first one to do crystallography and find the resolving insulin. But it took an enormous time, 35 years of work. And still, insulin was crystallized already in 1925 by Abel, professor of pharmacology at Johns Hopkins University. And she has expressed this herself in a review from 71. I used to say, the evening that I developed the first X-ray photograph I took of insulin in 35 was the most exciting moment of my life. So these are the eye-opener. But the Saturday afternoon in late July 1969, 35 years later, 34 years later, when we realized that the insulin electrolyte protein turbo runs the moment very close. So insulin has been the focus and the target of very, very fundamental work, including the 3-dimensional structure. I just show this en passant. This is my 5th book on Nobel Prize, but I wanted to show it because the lady in the middle, Gerty Cori, is the first woman to receive a Nobel Prize in Physiology and Medicine. She shared it with her husband, Carl Cori, on the right, and they got half the prize. And she was studying glucose metabolism, glycogen, and so forth. So it certainly belongs in this context. But the second woman to receive a Nobel Prize in Physiology and Medicine, Rosalind Yalow, what did she do? She developed a very sensitive test, a radioimmune assay for peptides. And what was the peptide? Insulin, of course. It was the first that was the test peptide. So it's a part of the history of medicine. And then just later on, we gave a prize in chemistry in 1980 to Paul Berg. And this was the time when one has learned enough to allow the production of in bacteria of vertebrate proteins. And that opened the door to also synthesize insulin in bacteria. And you know the story about the development in San Francisco of Biogen. And what was the first product that was produced? Insulin, of course, Humulin. And so it was first in vitro synthesis of insulin. Other byproducts of insulin production was, for some reason, ribonuclease. And I've been writing recently about the Nobel Prize in Chemistry 72. And they were using the ribonuclease to study the folding of proteins. And there, this was target material available in large quantities and also byproduct of the synthesis of insulin that made it very attractive. I won't elaborate on this, but in this analysis of the 1972 prize, I've come to extend the evaluation to protein folding, a very, very important field. And here, things have happened. You probably have heard of AlphaFold, but now we're talking about 2020 and AlphaFold 2. So all by a sudden, artificial intelligence allows us to interpret the folding of a protein, even complex proteins. And I asked one young colleague at the Karolinska Institute, could you just compare to me the traditional, on the left, X-ray structure of insulin, and what you get if you take the amino acid sequence of insulin and let AlphaFold 2 determine it. And isn't it amazing what artificial intelligence can do? They are absolute replicas. And so this is opening new field, but I won't elaborate that. But protein folding is an exciting concept, because now we realize, although insulin has a very rigid, and you've seen there isn't much flexibility in this molecule. It knows what interaction surfaces it had, but a lot of proteins turn out not to have a completely predetermined structure, but to have areas that are flexible, and then all by a sudden nature can do amazing things. Let me finish with a picture of a Canadian Nobel laureates, and there's a lot that could be said about this, of course. So after Banting and Best that broke this whole field open, Banting and McLeod that broke this field open, there have been 4 more Nobel Prizes in physiology and medicine. All of them, however, people or scientists that have worked in the United States. This is Huggins, this is Jubel and Wiesel, this is Steinman, who did the immunological work, and so Zach, the most recent one from 2018. But then there are also 6 prizes in physics and 7 in chemistry. And I haven't, these are in the natural sciences, but maybe you should be proud of the prize in literature to Alice Munro also in 2013. So what can we say from this? I hope a memory like this is an encouragement to get young Canadian scientists involved, and hopefully one of those days to be able to compete for a Nobel Prize. And that the first prize in 1923 was a major event and truly is something to celebrate. So thank you very much, John. I guess I've been a little over my time, but whatever, thanks.